Let us look at the next section, students. This section contains 8 questions. The answers to these questions are in the form of double-digit integers. Let us start with question number 25 now. In an atom, the maximum number of electrons with principal quantum number n equal to 4 and spin quantum number s is equal to plus half is x. So if you talk about the electron having n equal to 4, so in the fourth shell, there can be 4s, 4p, 4d and 4f. So 4s is going to have one electron which has a spin quantum number equal to plus half. Similarly, if we talk about p has 3 orbitals. So those 3 orbitals can accommodate a maximum of 6 electrons, but we need only those electrons which have s equal to plus half. So again, there will be 3. Similarly, for d there will be 5 and for f there will be 7. So if we talk about the total value, the value of x will come out to be equal to 16. If you talk about the second information, which says that the total degeneracy of the third excited state. So the third excited state means that the fourth orbit is taken under consideration. And since it is a hydrogen atom, so for hydrogen atom, the degeneracy is directly given by n square. All of 4s, 4p, 4f and 4d are equal in energy as per the Bohr model. So the value of y will be equal to 4 square, which is equal to 16 again. So students, the value of x is also 16, the value of y is also 16, and the sum has to be reported as 32. Let us look at the next question now. Question number 26. A compound with molar mass of 80 gram per mole is dissolved in a solvent having density of d gram per ml. Assuming no change in the volume upon dissolution, the molality of a 3.2 molar solution is found to be 4 molar. Report the value of 100d. So students, both the molality as well as the molarity is given to us. So we can just assume that let 1 kg of solvent be taken. So if the 1 kg of solvent is taken, students, then the number of moles of solute will be equal to 4. Now the density given to us is d gram per ml. So density of solvent is d gram per ml. So this can be simplified to d kg per liter. Now it is told to us that there is no change in volume upon the dissolution of the solid. So if there is no change in dissolution, it means that the volume of the solution will be equal to the volume of the solvent. And the volume of the solvent can be found out using the mass and the density data. If we talk about the volume of the solution or the volume of the solvent, it will come out to be equal to 1 by d liters. Now students, we have the molarity of the solution. So there are 4 moles of solute present in 1 by d liter. So the molarity value is given to be equal to 3.2. So on solving, we have 4d equal to 3.2. So the value of d will come out to be equal to 0.8. So students, we have to report the value of 100d, and the value of 100d will come out to be equal to 80. Students, for this question, we have to mark the answer as 80. Let us look at the next question now. Question number 27. Consider the PV versus P diagram given below for 4 different gases H2, He, N2 and CO2, not in order at 0 degree C. If the graph of H2 be represented by the number x and the graph of N2 be represented by the number y, then the value of x into y is. So students, if we look at the graphs given, we can clearly see that H2 and He have to be 1 and 2 and N2 and CO2 have to be 3 and 4. So if we talk about H2 and He, we know that the graph of H2 lies above that of He. So 1 is for H2, the second graph is for He, the third graph is for N2, whereas the fourth graph has to be CO2. So if we look at the values x and y given to us, so the x has to be equal to 1, whereas the value of y has to be equal to 3. So students, for this question, we have to mark the product of x into y as 0, 3. Let us look at the next question, students. Question number 28. An element crystallizes into the body-centered cubic structure. The volume of the unit cell is 64 into 10 to the power minus 24 centimeter cube, and the density of the element is 12 gram per centimeter cube. The atomic mass of the element is x gram per mole. Report the value of x by 10 closest to the nearest integer. The value of Avogadro number has to be used as 6 into 10 to the power 23. So we can directly put the formula of density, students. So density is equal to Z, which is the rank, into the molar mass m0 upon volume upon Avogadro's number. So we can just substitute the numbers which are given to us. The density value is 12 gram per centimeter cube, or the rank of the unit cell is equal to 2. The molar mass we have to report. The volume given to us is 64 into 10 to the power minus 24, whereas the value of the Avogadro number given to us is 6 into 10 to the power 23. So students, if we solve this expression for the value of m0, we get the value of m0 as 230.4 grams. So this is the value of x, and since we have to report the value of x by 10, so the value of x by 10 will come out to be equal to 23.04. And students, when this is reported to the nearest integer, it has to be reported as 23. Let us look at the next question, students. Question number 29. Consider the half cell. So we've been given M2 plus aqueous plus 2 electron giving us M solid. The standard EMF of the half cell is found to be 1.4 volts, whereas the temperature coefficient is found to be 2 into 10 to the power minus 6 volt per Kelvin. If the value of delta H for the above reaction at 300 Kelvin and M2 plus ion concentration equal to 1 molar is minus x kilojoule per mole, then we have to report the value of x by 3 closest to the nearest integer. Students, if we talk about the temperature coefficient which is given to us, so we know that dE by dt is equal to delta S by NF. So the value of N is equal to 2. So this value given to us is equal to minus 2 into 10 to the power minus 6. So we can clearly see that the value of delta S comes out to be equal to minus 4 into F into 10 to the power minus 6. We can now talk about the delta H for this reaction, students. The delta G value we can find out using the standard EMF which is given to us, students. So delta G naught is equal to minus N into F into E naught. So the value of N is equal to 2 F, and E naught value given to us is 1.4. Okay. So this gives us a value equal to minus of 2.8 F. So students, since we know the value of delta G naught now, so it has to be equated to delta H naught minus T delta S naught. To find out the value of delta H naught, we just have to put in the value of delta S naught that we had calculated before. So students, if we talk about delta H naught minus T delta S naught, it shall be equal to minus of 2.8 into F. So we can put the values. The value of temperature is equal to 300 Kelvin. So 300 into negative will make a positive, 4F into 10 to the power minus 6. So this is the value of this term. So this gives us a value equal to 1200 F into 10 to the power minus 6. So this gives us a value equal to 0.0012 into F. Okay. So now we have the value of delta H naught equal to minus 2.8 F and minus 0.0012 F. So this comes out to be equal to minus 2.8012 into F. So if we put the value of F as 96500, we're going to have a value of delta H naught equal to minus 270.32 kilojoule per mole. So students, the value of X, as we can see, comes out to be equal to 270. So the value of X by 3, which is closest to the nearest integer, has to be reported as 90. So students, for this question, we have to mark the correct answer as 90. Let us look at question number 30 now, students. 1 mole of an ideal monatomic gas undergoes a reversible process in which PV raised to the power 4 is a constant. We have to comment on the heat capacity of the system. So it is given to us that the heat capacity of the system is XR. Then we have to report the value of 30x. So if we talk about a polytropic process, students. So for the polytropic process, PV raised to the power n to be a constant, the heat capacity C is given by CV minus R upon n minus 1. So since the gas is ideal monoatomic, so the value of CV shall be equal to 3R by 2. Look at the value of n minus 1. We can clearly see that the value of n is equal to 4. So this must mean that the value of n minus 1 shall be equal to 3. So on simplification, we have a value equal to 7r by 6. So students, now we have to report the value of 30x. So the value of x is 7 by 6. So 30x will be equal to 35. So students, for this question, we have to mark the correct answer as 35. Let us look at the next question now. Let us look at question number 31 now, students. So consider the simultaneous equilibrium in a 1 liter container. So we have 3 reactions. Okay. It is mentioned to us that initially 1 mole each of P and S are present, while at equilibrium, the concentration of Q is equal to T and the concentration of S is equal to 5 by 6 molar and the concentration of R is equal to 1 molar. The value of S is found to be X times the concentration of P at equilibrium. We have to comment on the value of 10x. Students, we need to solve these equations simultaneously. So we have P in equilibrium with Q and R. Further, we have Q plus S in equilibrium with R and T. And last, we have P plus T in equilibrium with R and S. Okay. Students, the initial concentration of P is given to us as 1 molar. S is also 1 molar. So P and S have to be made as 1 molar initially. Now, if we assume that X amount be dissociated from P, so the amount of Q and S formed will be X and X. So in all the equations, we have to make the concentrations of Q and R as XX and the concentration of P as 1 minus X. Okay. So P has to be made 1 minus X, whereas Q and R have to be made X. So Q is X, R is X, R is X. We can now talk about the second reaction now. We can assume that Y amount be dissociated. Okay, so 1 minus Y giving us X plus Y and Y. So the concentration of R has to be made X plus Y everywhere. And if we talk about S, S has to be made 1 minus Y everywhere and Q has to be made X minus Y everywhere. We can now talk about the T. So T also has to be made as Y. Now we can talk about the third reaction now, students. We can have an amount Z dissociating. So 1 minus X minus Z, Y minus Z, X plus Y plus Z and 1 minus Y plus Z. Okay. So we have to change all the concentrations accordingly. So T is equal to Y minus Z. P is 1 minus X minus Z. R is X plus Y plus Z. And S is 1 minus Y plus Z. Okay. So we have to ensure that all these species have the same concentrations in all the given reactions. We can now have the data which is given to us, students. We have been given that concentration of Q is equal to concentration of T. So we have X minus Y. So we have X minus Y equal to Y minus Z. So this tells us that the value of X plus Z is equal to 2Y. Next, it is given that the concentration of R is 1 molar and the concentration of S is 5 by 6 molar. So concentration of R, if we talk about it, is X plus Y plus Z is equal to 1. From here, students, from 1 and 2, we can clearly see that the value of 3Y will be equal to 1. So we can have 3Y equal to 1, which gives us a value of Y equal to 1 by 3. We can now use this expression of S. So S is 5 by 6. So if we talk about S now, S is 1 minus Y plus Z. So this is equal to 5 by 6. So we can see that Y minus Z is equal to 1 by 6. So the value of Y was 1 by 3. So 1 by 3 minus 1 by 6 is equal to Z. So in solving this expression for the value of Z, students, we have the value of Z as 1 by 6. So the value of Z, students, is 1 by 6. So automatically, since the sum of X plus Y plus Z is 1, so this must mean that the value of X has to be 1 by 2. So students, we have X is equal to 1 by 2 and Y is equal to 1 by 3 and Z is equal to 1 by 6. So we have to comment on the ratio of the concentration of S to that of P. The concentration of S has been given to us directly. It is equal to 5 by 6 And if we talk about the concentration of P, students, the concentration of P will be given by 1 minus X minus Z. So we can see that this value will be equal to Y. So this has to be equal to Y, since the sum of X plus Y plus Z is equal to 1. So 5 by 6 upon Y, so Y is 1 by 3. So if we solve this ratio, we're going to have a value equal to 2.5. So the value of X is 2.5, which implies that the value of 10X has to be 25. So students, for this question, we have to mark the answer as 25. Let's look at question number 32 now. Elements X and Y of third period form binary compounds P and Q respectively with fluorine. Some information is given below. So compound P is non-polar and has only 6 bond angles of 90 degree each. If we talk about compound Q now, it is non-polar and has only 12 bond angles of 90 degree each. So if we talk about the species which has 6 bond angles of 90 degree each only, and it is non-polar, so it has to be PF5. And if we talk about the compound Q which has 12 bond angles of 90 degree and non-polar, so it has to be SF6. So compound P is PF5 and compound Q is SF6. Number of lone pairs present in each molecule of P and Q are A and B respectively. The value of A plus B is. So if we try and draw the structure of PF5. Okay. So there is no lone pair on any of the phosphorus atoms, while there will be 3 lone pairs each on every fluorine. So the number of lone pairs in this molecule is going to be 15. Whereas if we talk about SF6 now, so in a similar fashion, there will be no lone pairs of electrons over sulfur, whereas each fluorine will have 3 lone pairs. So B will be equal to 18. And if we talk about the sum of A plus B, it has to be reported as 33. So students, the answer to this question is 33.